Ok, vous m'entendez? Oui, je pense. Hein. Parfait. T'es pas sûr? Est-ce que tu m'entends, Anne? Au fond? Parfait. Ah, il y a encore des gens qui arrivent, donc on va laisser les personnes prendre place. Bienvenue à tous. Ravi de vous revoir après une longue pause forcée. On reprend nos activités. La Maison de l'Architecture reprend ses activités. On reprend le cycle qui avait été interrompu et qu'on va mener à bout ces prochaines semaines et mois, le cycle Momentum. Aujourd'hui, c'est un peu spécial, vous l'avez compris, puisque nous sommes ici au pavillon Cycli, mais en même temps, nous sommes en live stream par notre site internet et Facebook et également sur le site du bureau Arabe. Le conférencier de ce soir étant anglophone, la conférence, vous l'avez compris, se tiendra en anglais. Et donc, mon introduction, je l'ai également préparée en anglais par courtoisie. Good evening, everyone. From this beautiful and timeless pavilion here in Geneva, Switzerland, la Maison d'Architecture de Genève is happy to welcome you back to our 2020 conference series on the theme of Momentum. Momentum is a neologism that has many meanings: dynamics, rhythm, impulse of the moment, conjunction, or opportunity. Momentum questions the element of time of each project and the conditions that influence them, all of which are perhaps very personal. Momentum also seeks to question the relationship between time and the act of creation, more specifically, the act of building. Tonight, as an engineer, it's an immense pleasure for me, truly an honor, to welcome our speaker, Mr. Tristram Carfrae, Deputy Chair of Arab. Tristram is a structural engineer, but more than that, he is a total designer. In his own words, he is a global designer. In Tristram's practice, there is no limits between architecture, structure, energy, sustainability, digital fabrication, and industry. He has worked on some of the most innovative and iconic constructions in the world, such as the Beijing Aquatic Center, also called the Water Cube, and Singapore's Marina Bay Double Helix Bridge. He is presently leading the Arab team in completing the extraordinary Sagrada Familia in Barcelona, to be finished by 2026. Thanks to his rich career, as well as his vision of engineering and design processes to serve society, Tristram Carfrae has gained world recognition, along with Sir Ove Arup and Peter Rice before him. He was appointed a Royal Designer for Industry in 2006 and received the Institution of Structural Engineers Gold Medal in 2014. After Tristram's talk, I encourage you to take advantage of this golden opportunity to ask him about his career and work. If you would like to pose your question in French, just speak up and we will be glad to translate it. Tristram, thank you very much for being with us tonight. The floor is yours.
Well, thank you very much for that kind introduction. And I apologize that I'm going to present in English and not in French. And also apologies for not being there in person. I'm sure you'll understand the reasons for that. But nevertheless, let's see what we can do with our modern technology. So I am absolutely delighted to be talking to you today about this amazing building in Barcelona, Sagrada Familia. I will be telling you a bit about its history, a bit about how Arab got involved with it, and a bit about what we've been doing for the last 5 or 6 years. Before I begin, though, I have a bad habit of talking as though I personally did everything, and that is never the case, and certainly not in this project. All projects, in my experience, are team efforts with tens, if not hundreds of people contributing ideas and their enthusiasm, passion, and indeed putting a bit of themselves into the final construction. But in this case, we have a very particular project setup because the client, the architect and the builder are all the same. They are the Sagrada Familia Foundation themselves. The only external parties are two firms of engineers, one in Barcelona, 2BMFG, who've been working on the project for 30 years or more, and more recently, the newcomers to the project, Avec. So we'll start with the 130 years before we became involved. Going back even further than that, in 1860, Barcelona had this amazing vision of creating the Eixample, or the extension. At that time, the contents of Barcelona were just what's now called the Gothic Quarter, the medieval city down in the bottom left of this picture. But they created this amazing plan for extending the city using these iconic blocks with their corners chamfered. And you'll notice that in the original plan, the blocks are only occupied by buildings on 2 or 3 sides, with public space in the inside of each of these blocks. The red dot, of course, is the position of Sagrada. And then if we look today at the city of Barcelona, we find that they have pursued faithfully that plan, at least in terms of the block layout and the chamfered corners, although nowadays almost every block is built on all 4 sides, and the public space has become private, if indeed it exists at all. Sometimes it's built completely. But again, you see the position of Sagrada. And when Sagrada started, when the devotees of St. Joseph, a private organization, decided to build a church in 1878, this area was light industrial, slightly agricultural, and had virtually no construction. It was not yet incorporated into the city of Barcelona at all. The devotees of St. Joseph originally employed an architect called Villard, who designed for them a very classical Gothic church, fairly sizable, but not enormous. And that church was started construction. So the crypt of that church was constructed to the extent you see before you today, when in 1882, Mr. Villard and his client had a disagreement and he resigned from the project. Whereupon the client, the devotees of St. Joseph, took the extraordinary step of appointing Antoni Gaudí as his successor. At that time, Antoni Gaudí was only 30 years of age, and the only thing he built so far in his career was this glove stand for the World's Fair of 1878. So they were decided to entrust their amazing project to this unknown architect. Of course, Gaudí went on to become one of the most famous architects in the early 20th century in Europe. This is the house he built for his patron, Mr. Güell. This is Palau Güell, for example. This is a shot of one of the outbuildings at Park Güell, which was an experiment in urban living. What was the ideal way for the middle classes to live in the turn of the 19th century? It's probably his most famous individual dwelling, which is Casa Bayo in the center of Barcelona. And you can see here also that at that time, Gaudí's style was very closely aligned with that of the arts and crafts movement, for example, in the UK. It was very much about craftsmanship, about decoration, about organic forms and shapes. And Gaudí's largest undertaking outside of Sagrada was for this block of apartments called Casa Mia. This was constructed in 1908, and it shows some of Gaudí's foresight. So this apartment building in 1908 had an underground car park accessible from a spiral ramp that you go through the main doors to access. So he was providing underground car parking for cars when there must have been about you know, one every half a mile on the streets of Barcelona or something like that. Another feature of Casamia, or La Pedrera, the quarry, as it became known, was an amazing public accessible roof space, an amenity at the top of the building. And I'd ask you to take note of the chimney pot you can see in the front left of this picture, because we're going to see it again later in the talk. So while Gaudí had maybe not a lot of experience when he was appointed, he showed no lack of ambition. So he took the Villars Church, you can see here outlined in blue on the right of the slide, and extended it somewhat to make Sagrada Familia, outlined in red, more than double the height, for example, and probably about 4 times the bulk. His ambition didn't even stop at the church, as this plan by Gaudí himself shows. He wanted the surrounding blocks to be all cut back at a skew angle, because he thought his church was more interesting when viewed at an angle than it was in straight elevation. And he wanted, therefore, the 4 surrounding blocks to be curtailed or reduced to allow those views. And in fact, a lot of that happened. Here is a map from Google Maps today, and you can see on the left and the right of Sagrada, which is outlined with the yellow circle, are 2 open blocks. They're made public parks. And an avenue at 45 degrees was created to the another famous modernista building, the Hospital de la Santa Cruz, to the northeast, sorry. And that avenue, you know, appropriately enough, is called the Avenue Gaudí. And then this last image is part of the sort of the preamble, if you like, to the church itself, is to remind you that as stated in the introduction, I'm used to working at the intersection of architecture, engineering, and construction. But in this case, there is also theology. Every part of the church has a theological meaning, very carefully appropriated and defined by Gaudí, who was very religious himself. And so it's no good me going to a meeting and saying, we don't need 7 columns, we can do with 4, if I don't acknowledge that there are 7 graces and 7 deadly sins, and therefore there will be 7 columns, whether they're totally necessary or not. So during Gaudí's lifetime, he spent 44 years of his life working on Sagrada. Initially, he did other projects as well, some of which I've already shown you. But for the last 20 years of his life, he really did nothing but Sagrada. He was totally dedicated to it. And during his lifetime, these are the parts that were constructed. It was constructed the north wall around the end of the crypt, around the end of the apse, you can see here on the left, and the east entrance, the nativity facade, and its 4 bell towers you can see on the right. And here you see the nativity facade in all its glory. This, of course, is a modern picture, and it shows a lot of sculptures and decorative work that weren't there in Gaudí's days, but the basic configuration, the storytelling, the sculpture, and the presentation, if you like, of this amazing doorway was entirely constructed during Gaudí's lifetime. And it has some of his wonderful quirks. You probably can't tell, but under the left-hand pillar, there is a turtle, and under the right-hand pillar, there is a tortoise, and that's because the sea is to the left and the land is to the right. Of course, it's a combination of a classical representation of the nativity, as you see the birth on the right, but also the carving of the stone is meant to represent life emerging from the primordial mud. So it is life in all its guises, if you will, are represented on this doorway. And the work continues to date. So this doorway here, these bronze doors were only installed three years ago. They're the work of a Japanese sculptor named Mr. Sotu, who joined the team in 1978 as a stonemason, learnt sculptor, and is now head of the whole decorative arts project. And one of the things I noticed about Sagrada, and I've noticed it even in my own team, is the challenge of adding to this amazing building. It causes people to do special things that I think they might not have done otherwise. And Mr. Sotu here is a good example of that. So when Gaudí died in 1926, this was the state of construction. As I said before, the apse on the left, nativity facade at the back. And you can see that the Eixample itself is now also coming into being, not completely, but in part around the church itself. And then in 1926, on his way to Evensong, he went to pray every day. Gaudí was unfortunately struck by a tram and died on his way to the church to make his prayers. By that time, he'd become totally ascetic. He was living more like a tramp than as a member of the middle classes. So even though he had his own villa at Park Gwell, he'd actually become, his habit was to sleep in the church itself at his desk, at his design desk. And it was actually 2 or 3 days after he was killed that he was recognized as the famous Anthony Gaudí and recovered from the morgue, from the Paupers Hospital, and given a state funeral. It's always been a bit of a puzzle to me as to why he built so much of the church, or so little of the church, if you will, from the ground to its pinnacle, rather than the more conventional building a bit of everything. And it could be that he wanted to make sure everybody understood his design intent by completing complete parts of the building during his lifetime. Or it could be, and possibly more likely, that the whole of the church has always been funded by private donations, and he simply wanted to make the best possible advertising hoarding to make the money flow, or help create the money flow that would be needed to complete the building after his death. Then in the Civil War, prior to the Second World War in Spain, most unfortunately, the building where all the designs and documents and these plaster models, Gaudí worked a lot from plaster model scale models, were blown up by a bomb. So a lot of the documentary evidence of Gaudí's intention was apparently destroyed. Fortunately, a good deal of the plaster models have been painstakingly glued back together again. And indeed, this process continues today. There are model makers in the basement of Sagrada trying still to figure out how little bits of smashed plaster fit back together again. And a lot of the documents were recovered because they had been published either in other exhibitions or in works to do with the fundraising exercise. And those documents were repatriated. So we actually ended up with a fairly good idea of Gaudí's design intent. Construction didn't start again until the 50s, after the Second World War, another period after that period of unrest, if you will. And they started on the western facade, the nativity facade, the Passion facade. So this facade is in absolute stark contrast to its mate on the other side. One is totally about life, and this one is the opposite. The west-facing facade is completely about death. Again, it tells the classical story of Christ's own death, but more by it representing by bones, if you like, or a skeletal approach. It represents death in every other manifestation as well. And in fact, although it was started in the 50s, the pediment of this facade was only put on about 5 years ago, and the cross, when the two sculptures on the left and right, the lion and the lamb, were only put in place last year. This was the story I referred to earlier. You'll notice on these wonderful sculptures by a Spanish local sculptor called Joseph Subirax, in his sort of cubist fashion, that the helmets of the soldiers, both on the horse to the left and facing you in the middle, are actually modelled on the chimney pots of Casimir in a sort of act of homage to Gaudí himself. So Gaudí started, as I said, as this sort of figurative arts and crafts architect, but he changed over his lifetime. And you can see he changed in the style he used for Sagrada. So these are the original designs from 1890. They are neo-Gothic in style, if you will, although he'd already taken a decision that he didn't want buttresses or flying buttresses outside his church. He felt that this prevented the amount of light coming into the church that the church would benefit from. And he also thought it was a purer representation of masonry and structure if you could bring the loads to the ground without the need for external crutches or props to support the outside walls. So you can see in the middle of the section on the left this idea of a catenary arch, which I'll tell you more about later, as a way of avoiding the need of flying buttresses. So this photograph here of the inside of the Nativity facade, the facade built during Gaudi's lifetime, shows you clearly this neo-Gothic approach that he had with a slightly modernist twist, as opposed to the columns in the foreground, which are from the third epoch of his design. Oh dear. I'm sorry, I've clicked on something that means I no longer have the slideshow in front of me nor can control it. If somebody could help me rescue that, that'd be great. So while we're waiting for the slide, I presume you can't see it either, which shows the second epoch of his design. This one shows the development of the first epoch, where he's beginning to take the structural shape of the building more making it more important. We'll just try and catch up with where we were. So he's shaping the building more in terms of the forces that the masonry, we've gone too far. Okay, this is the slide. So you can see on the section on the left here, we've got inclined columns at the bottom. And all this is to do with trying to take the structural loads properly down to the masonry. As far as I'm aware, Gaudi didn't use a structural engineer. He worked all this out for himself, and we'll see a bit more in a moment. At this stage, it's a sort of halfway house. He's moving on a bit from his original idea, but he's still got these sort of horizontal platforms where the columns are brought together and then branch out into the next level above. He hasn't yet had the confidence to do this in free space. But about this time, Gaudi also resurrected a technique from the 18th century, which was if you wish to design a building which uses stone purely in compression, then one way of working out the perfect shape is to use chains that are purely in tension upside down and add weights, in this case, little bits of lead shot in canvas bags that represent the weight of the masonry at every point of the church. So this is an enormous undertaking because every time you change one of the weights, it changes the shape of the hanging chain model, which changes the amount of masonry that will be at that point in the real church. And therefore you have to change the amount of lead shot in the bag again and again and again. And I estimate it would probably take a year to get this model to eventually converge on a final shape. This model is not actually of Sagrada at all. It's of a church or a chapel that was proposed at Colonia Güell, another undertaking to find out the ideal way of rural living outside of Barcelona. And the only part of the chapel that was built was the basement. And this is it. Oops, one slide too far. No. Right. Yes, sorry. So this is the basement of the chapel at Colonia Güell. And you can see that I think that Gaudi was using it as a vast experiment for Sagrada at the expense of his client, Mr. Güell, because every single component of this seems to be an experiment in different materials as well as geometry. So we have brick columns, we have concrete columns, we have single columns made out of single pieces of granite, columns made out of single pieces of basalt. And we have, in the end, a fairly confusing, dare I say, discombobulating space, because none of the columns are upright. They all incline in different directions in response to the load path coming from the church above, which was actually never constructed. So I think Gaudí learned from this, so that in his third and final design for Sagrada, while he did a perfect cross-section from a structural point of view, with all the loads being brought down properly, with the columns now branching in free space on their way up to pick up the different parts of the building further up, in the other direction, he simply repeated this two-dimensional structural diagram at regular intervals. And in fact, he imposed a grid of 7.5 meters in both directions and indeed vertically to produce a sense of order to his final construction. And this is the nave that was then under construction in the late part of the 20th century and the early part of the 21st century. You can see it marching towards you in its regular, repeatable cross-section. It was then completed in 2010 when it was consecrated by the Pope. So the whole church became fully enclosed. And I have to tell you that from my experience, this is the most uplifting and amazing space I've ever been into. I think the sense of verticality and light that comes from the top of the church is quite incredible. And it was achieved also by the stained glass here. So on the right, you can see the stained glass is of cool colors. It's of green and blue. And that, of course, is the eastern facade where the morning light comes in. And on the left, you can see it's of warm colors because that's for the afternoon light. And so the church also changes its character completely during the day. And then the upper levels of stained glass are actually all crystal clear. They're not colored at all, to introduce this idea of light at the top of the building and the sense of verticality, and you're looking upwards. At the same time as Gaudí took on structure, he also took on geometry. And every single part of his third design for the church is made from a ruled surface, a surface with straight line generators, either a hyperbola, which you can see here on the left, or a hyperbolic paraboloid, which we'll come on to later. So in the ceiling of the nave, you can see on the right, all those vaults are hyperbolic paraboloids. You can see that the straight line generators are represented in the tiles. They're also represented in the decoration. So the little teeth hanging down are not arbitrary. They are the intersections, or formed by the intersections of the generatrix of this hyperbola and its adjacent one. So everything had meaning and purpose. The other reason he used a hyperbola was he thought if he used that shape for the windows, it maximized the amount of light that could get through that particular opening, because there was a ray of light that could just touch the surface of the window on one side and emerge grazing the surface of the window on the other side, in sort of a perfect ray of light being traced through the opening. Here you see examples of this on the ceiling. On the left is the big hyperbola at the base of the main tower, which we'll be talking about later. On the right is the elegant hyperbola at the bottom of the Mary Tower, the front tower sitting on top of the apse, which is also the golden triangle here, also made from the generatrix, represents God, his or herself. And here's a ceiling plan, a reflected ceiling plan, or a photograph of the ceiling, where you can see on the left the back of the Passion facade, on the right the back of the Nativity facade. Down the page you can see underneath the big Mary Tower and that triangular representation of the Supreme Being, and up the page is the main nave, which eventually will get to the Glory facade, which we have yet to design. So that's the state of play as of 6 years ago, in 2014, when Sagrada came to London and approached us in Europe and asked for our help, or whether we were able to help. And they wanted the help with three different aspects of construction, if you will. The first is that at that point, 60% of the building had been constructed, about 40% was yet to be constructed, and yet they'd set themselves an ambition to complete the church by 2026, which was only 10 years away. And these are all the parts yet to be built. The two sacristies at the north end that you see there, the main Mary Tower, which is standing above that representation of God, but it also stands directly above the original crypt for Villars Church. The main nave roof and this room at the bottom of the main tower called a crossing, the bases of the evangelist towers, the pediment on the Passion facade, which I've shown you is now already complete, the baptistry on the left and the penitent's chapel on the right, the main glory facade and its amazing canopy hanging out over the street at the south of the church, 4 more bell towers representing the completion of the 12 apostles, the 4 evangelist towers surrounding the main tower dedicated to Jesus Christ himself, crowned with an accessible cross. And when the building is finished, it will be 172.5 meters tall, a multiple of 7.5 meters that I referred to earlier, which will make it the largest, tallest building in Barcelona, the tallest church in the world, but 1 meter less tall than the hill at Montjuic, because Gaudí thought it was rude to challenge God and he would stay just slightly different. So our challenge basically was, can we build the remaining 40% of the church in 10 years, which roughly means speeding up the rate of construction by a factor of 10, at a time when your site access becomes increasingly limited, and at a time when we still need 4 million visitors every year to come and buy their entry tickets, because that will pay for the construction. So the construction has to proceed while visitors are attending and visiting the church underneath. That was the first part of the challenge. The second part of the challenge is that for the Mary Tower, as I said before, sits above the crypt and therefore had to be only of a certain weight, because the foundations of the crypt never envisaged the mass of the tower that Gaudí proposed to put on top of it. It was formed for the much smaller Villar Church. The geometry of the Mary Tower can be extrapolated because one of the plaster models that has been recovered and reconstituted was for the sacristy you can see in front of you. And the geometry is actually the hyperbolic paraboloids rotated about a central axis and then intersected to form the shape you can see on the right. We can now use our newfound skills in the digital world of Grasshopper and Rhino and take that form for the sacristy and simply extrude it into a taller, more multifaceted shape for the Mary Tower, as you see in front of you. And by the way, I should point out that the architects, designers at Sagrada were pioneers in the digital world. They adopted digital techniques from the early 80s of the 20th century onwards, partly under the influence of an Australian architect, Mark Burry. So we know what shape the Mary Tower is, as you can see in front of you. But the question is, what can we make it of, or make it from, or how can we make it that is both quick and lightweight? And the proposal brought to Arup 5 years ago was to build a steel tower and clad it with lightweight cladding panels that could be made to look like stone on the outside. And the third part of the challenge, of course, was to remain true to Gaudí's intent. And this is a continuing debate, is how do you do that? How do you continue to reinterpret such an amazing genius and stay true to what he intended? And some people will say we shouldn't. Some people believe that nobody should attempt to complete the church because it will never be, as Gaudí intended. But Gaudí himself wrote that he expected the church to be completed by future generations. So I don't think that's necessarily the right approach. But there is always a debate. What would Gaudí have done? What did he intend before he died? What would he have intended if he'd still been alive today? These are always part of our continuing debate. So when we took up the challenge to see what we could do, our first way of approaching it was, what else do we know or can learn that could help us with this challenge? And so we knew a lot about steelwork. At Arup, we just completed the Leadenhall building, the cheese grater in London with Roger Stirk Harbour and Partners. We had finished the orbit, whether you like it or not, in the Olympic Park, Anish Kapoor's sculpture. But we also knew a bit about using stone in a load-bearing capacity. This facade was for this building at the future, Pavilion of the Future at the Seville Expo in 1990, which I'd worked on previously in my career with Peter Rice. And we'd designed this church with Renzo Piano called Padre Pio, which also used post-tension stone. You can see the holes in the stone because they're actually inside the stone. There are steel cables post-tensioning it to make it into these wonderful arches. And more recently, I've been spending time in Sydney and have designed this sandstone sculpture, which also used post-tension steel rods. You can see the ends of them poking out of the holes in the sandstone. So we had some ideas that weren't necessarily about using just steel. And so what do we do with those ideas? Well, what I normally do, and did in this case, is to experiment with computer analysis, or what I call simulation. What if questions all the time. What if, what if, what if? And at the end of a month's sort of experiments, we came to the conclusion that actually, if we made the tower out of stone panels, as you can see here, this is a part of the tower near its base, and we made them out of stone, then if the wind blew, these are the stresses you would get in those stone panels. But the green is compression, which is what masonry loves. The red is tension, which masonry can't stand because it simply opens up the joints between the stone blocks. So if we just use ordinary stone masonry, made panels of the right weight, which is making them quite thin, then this is the consequence. There's not enough weight in the tower above to hold it down when the wind blows. But if we also introduce steel rods inside the stone and post-tension it, clamp it together using pre-established forces in the steel rods, then we can introduce compression forces in the stone that look like this. And now when the wind blows, you can see there are only very modest areas of tension and ones that we don't really need to worry about. These will crack some of the mortar joints perhaps in an unnoticeable fashion, but that's all they will do. They won't threaten the structural integrity. So this is the proposal we took to Sagrada. We said, what can we do, or how can we approach it using post-tension stone panels, which we can make off-site and assemble on-site to speed up construction, to do minimum work on-site so we don't interfere with the visitors down below, and to use less stone and keep the weight of the building down. And the wonderful response from Sagrada, because they're also the builders, is within a month they made a panel. They thought, well, what's it like to build? Do we like it? Do we enjoy, carving up bits of stone or cutting stone blocks and clamping them together with steel rods that you can see here? And so we made a piece. We brought it to site to see how it looked, in context of the church itself. And you can see from this shot that the answer was everybody was delighted. So second from the left is the builder, the man in charge of construction at Sagrada, and he was overjoyed. He thought this was going to make his life much simpler. The other advantage of making a mock-up or a prototype is that you can then test it. So here we are testing it with a hydraulic jack in the foreground to see that it does behave in the way that we predicted with our finite element computer simulation. Very briefly here is just, I think this is a job or the project I worked on, which has had one of the greatest levels of collaboration. And it might be because there's a bit of a language barrier between ourselves speaking English and the local team who like to work in Catalan. But it might also be because everybody is absolutely focused on the quality of the outcome and nothing else really matters. But whatever it is, we sketch, as you can see on the left, we sketch on top of computer models, as you see on the right. We use computer representations, both geometric ones on the left, rendered ones in the middle. We make 3D rapid prototype models all the time, or at least the architects in Sagrada do. Every time we go for a workshop, there are new models made. We made computer models representing the way it should be constructed, stages of construction. The builder made the model on the left to see whether he could get his hand in to do those bolts up. So he's making a model using form ply. And on the right is a model made by the architects where every piece of stone is individually modeled as a plastic block from the rapid prototyper, the 3D printer. And then there's actually a steel rod in the middle that holds it together. Now, I think they were just checking that our structural theory was real. And, this was a valid way of making stone panels. And then lastly, this is a sketch by our project director, Steve McKechnie, articulating how things could be put together, how details worked. And what I love about this is that this sketch is entirely done digitally. This is done on an iPad in his very, his own idiosyncratic style. And the point of all of this is what I like to tell people is you have to be able to communicate to be a successful collaborator, but how you communicate is up to you. And my generation tend to say you have to do it with a felt pen. And I'm trying to say, no, there are multiple ways of communicating. The point is simply that you have to communicate. So finally, then, we have our proposal. What are we going to do? And in the modern world, we can do all this in the virtual world first. So we can build completely accurate models of what we want. Every component is present to the nearest fraction of a millimeter, the stone, the steel rods, the anchor blocks. This is a typical panel that makes up one of the evangelist towers. We introduced steel columns in the corners, not strictly necessary, but they helped a lot with construction. Those are the steel anchor blocks. Those are the steel post-tensioning rods. And there you see the panel itself. And then for real construction, you start with great big blocks of stone that you've taken out of quarries from all over the world. The original stone of Sagrada all came from a quarry at Montjuic in Barcelona itself, but unfortunately that was closed for environmental reasons in the 70s. So now sandstone that looks similar is sourced from all over the world. And then we cut that stone using a computer-controlled diamond-tipped bandsaw. This one actually isn't one of our saws, but it shows you the technique very, very well. And so you get this bandsaw, you can manipulate it in space, water jet it to keep it cool, and it cuts the stone. In our case, we use the bandsaw on the left. It does the same thing, but it uses a computer-controlled turntable that reorients the stone down below. But the point I'm trying to make is that this will cut any stone to any shape, provided it's a ruled surface. So I think it's wonderfully sort of coincidentally beautiful that the technology we use today is in perfect harmony with Gaudi's geometric approach from the 1920s. Then once the stone is made, we get this. So there you go. And in time-honored fashion, the front face of the stone is split from the main stone. So we get this beautiful hand finish, which is absolutely consistent with the rest of the church, or indeed with any cathedral built, from the 1200s onwards. I also like the fact on the right, you can see we're still using cardboard templates, again, like we did in the 1200s, to check that we built the right shape or made the right shape. And so via this process, we can mass produce the stones. The pockets required for the anchor blocks are carved out using CNC-controlled milling machines, again, with complete accuracy. And the builder then produced this series of videos. I'm going to show you two of them. This is how to assemble the lintel, the block at the top of the panel, and how you start by placing the anchor blocks. You use a laser cut template to make sure that each anchor block is accurately positioned relative to each other. You then also position the end ones using these plates, which are used as part of construction. The anchor block is then epoxy glued into place with epoxy injected into the cavity to make sure it's firmly fixed into the stonework. All anchor blocks, of course. And this video shows every single step that you have to take to manufacture a panel. This is just a clip from it. You have to bake the epoxy to cure it. Then you can remove the templates that held the anchor blocks in place. You now put in the post-tension rods that you're going to use to stress the stone itself. And along comes, this is the stool for the hydraulic jack, which is then applied, done up. You add the hydraulic coupling, in comes the oil, extends the rod, and then you tighten it using the stool, and then you take the jack off, etc. So the builder's premise was that if he could put, and this is a quick video just showing you some of those steps in real life, and it follows exactly what the builder intended to do. And he said that making those videos forced him to pre-think every step of construction, and it also has the advantage that he can train up more and more people to come and work on site by using the videos as a training material for people to join the team. So that's replayed. Oh. Yeah, and so then you get mass-produced lintels complete with their post-tensioning and anchor blocks. The second video then shows what's happening off-site at a yard at 1.5 hours outside Barcelona, where jigs have been established in which the actual panels can be assembled from the individual blocks. And here you see the mortar being applied between them. You can see laser cut plywood again being used as templates so that all the stones go in the right place. And again, this is a pre thinking through the assembly process. There are the rods being inserted into the panels. Those two have to be inserted from the top prior to the lintel being placed, which we just saw being made in the previous slides. Then the final rods are introduced. And again, we then couple up the rods. These are the dead ends at the end away from the jacks. And then we add the jacks and post-tension the rods. So on site, in reality, what happens is that there's a kit of parts produced for every panel. All the steel components, which are made from a very long-lasting duplex stainless steel, because we're trying to make the church last as long as possible. They come in boxes, 1 box per panel, just like with your IKEA furniture. Here is the actual jig on site that makes a whole row of panels for one tower at one time. Here you can see the laser cut template at the bottom, where the shear keys are inserted. That was used also for the anchor blocks of the panel below that we saw in the earlier video to make sure each panel fits one on top of the other. Here you see stones being placed using the templates at the back. And the outcome is a set of panels, 1 row for 1 tower. This is the first installation of the first panel, on the Mary Tower. And we can see the shear keys there on the right-hand side. Now, one thing we had a long debate about was how accurately could you make these panels? And I'm afraid we insisted that if they could achieve plus or minus 1 millimeter tolerance on the shear key into its hole in the panel above, then we would never have to do any site adjustment or site surveying of the towers as they were constructed. We knew or would know that they would fit together. And after a lot of reaction saying they could never make something with plus or minus 1 millimeter, they actually accepted the challenge and achieved it. And here you see it happening. So the first panel goes into place, and they've allowed an hour per panel in their construction program. And I thought the first one might take 4 hours, but in fact it went in 23 minutes, which was, an amazing achievement. And here you see one of the big panels for the main tower, the Jesus Tower. So these panels weigh 25 tons each. They have to be brought through the streets of Barcelona in the early hours of the morning or late in the evening, as they are a traffic hazard. And here it is lifted up, and I'm grateful for Time magazine for this video of one panel being installed. And I think this is something we haven't properly capitalized on, which is the construction itself actually can be a piece of theatre. Now, unfortunately, this is happening at 6 a.m. when the visitors aren't yet on site watching it all. But I think we should glory in these, what we can now do, because the panels are accurately made off-site. They are simply lifted into in place. And even these on-site, it's a quiet, dry operation. It doesn't take that many people to do it. And I think it's a fantastic thing. So even these 25-ton panels only take an hour to get from the street into place and fully fixed. So we're now at the stage where a row of 14 panels for the Mary Tower can be placed in 6 hours. There's no scaffolding, there's no temporary support. They simply dock onto the steel columns which are already placed ahead of them, which are also self-supporting. And we end up with what you see in front of you. These shots are now a little over a year old. There hasn't been much construction since March this year for reasons we all know about. But this shows you the Mary Tower growing nearly to its full height. This is the inside of the Mary Tower without need for its steel skeleton, self-supporting using the thin stone post-tension panels. Here you see the whole thing, and you can see we're just now getting to be taller than the Nativity and Passion facades, so that the whole skyline of Barcelona is becoming altered permanently. And here another shot looking down on all 6 towers being built at once. So I should have said that while the Mary Tower required this lightweight construction, it was deemed to be so successful that we're now using it on all the towers, even the ones that could have coped with greater weight. So that brings me to the end of my talk, except just to say that, I cannot believe how lucky I am to have become involved with this amazing project. It's something, occasionally I pinch myself in the morning. I can't believe it's really true that I have the opportunity to contribute something to this building that will hopefully last for many years and give great pleasure to many people. So thank you very much.
Beautiful presentation, huge challenge, absolutely great. Now I open the series of questions. Here, I think that Lionel has some questions on the web. We have some questions here. First of all, quelqu'un dans la salle, est-ce que quelqu'un de la salle souhaiterait commencer la difficile série de questions? Allez-y en français si vous vous sentez plus à l'aise. Anne se fera un plaisir de la traduire. Est-ce que quelqu'un ose poser la première question? Ah, c'est toujours difficile. Oui, c'est pour ça que... Ah, excellent. Anne.
Well, I'm speechless. What is the secret to giving your imagination such free rein, such liberty? Do you have a secret?
I don't know how to answer that at all, except I think my feelings or thoughts today about what is design is it's simply the idea of not accepting the status quo and saying, is there a better way of doing something, whatever that is, and then being absolutely open to ideas, be they yours or other people's, and seeing what can be done with them.
It made me think that maybe what if is the key.
Absolutely. Couldn't agree more.
I'll remember that.
Thank you.
Thank you, Anne. Thank you, Tristram. Another question? I have a question for you. For the Sydney Opera House, Peter Rice found a solution using digital technology in order to build this complex masterpiece. Gaudí started the Sagrada Familia more than 100 years ago. Clearly, the design of this building was ahead of its time. Still today, it seems very innovative, as we said in your presentation. Was it never finished because the construction process could not follow such a complex design? And are these two constructions, the Sydney Opera House and the Sagrada Familia, and the context of the engineering challenge similar for you?
Yes, I think they are. And I think it's also noteworthy that in both cases, new construction techniques were developed by the challenge, because of the challenge faced by the designers and the builders. So the Sydney Opera House is made from precast post-tension concrete glued together with epoxy, which hadn't been used previously, but is now a relatively standard technique for long span bridges, for example. And here we're using post-tension stone at scale, I think, for the first time. And I think, you know, one of the points I didn't make is people ask me, it might be relevant to Sagrada, but what relevance does it have for construction more widely? And I would say that this use of technology, you know, using the virtual world and prefabrication and site assembly, combined with the use of natural materials that are both carbon friendly, but also are ones that people respond to emotionally, and craftsmanship, so that there's labor and love being applied to the building, I think is a fairly potent recipe for any building. It doesn't have to be just for Sagrada.
Great. Another question? Lionel, I think you have probably questions from the web. Yeah? Let me read one. Did Arup have the access to structural integrity of the existing structure that has already been built to ensure it would support the newer additions?
So we're very fortunate, as I said in the beginning, that the team on Sagrada is completely collaborative. And unlike most projects where there are either real or perceived contractual barriers between the different parties, those don't seem to feature on this project. And so in our case, we are working completely in partnership with 2BMFG, the local engineers who've been working on the Sagrada for the last 30, 40 years. And they have been responsible for the majority of the building on which we're relying for the support of the towers. So we don't have to satisfy ourselves independently because we are part of a team that is responsible for that work.
Great. Question here in Geneva? No, still not. It will come. I have a question, Tristram, but it's not related to Sagrada Familia. Tristram, you designed the water cube in 2008. At the same time, just in front of it, there was another construction. There was a construction of another masterpiece. I'm talking about the Beijing Olympic Stadium, of course, the Bird's Nest. Both are designed by Arup, but in opposition in terms of structural rationality, I would say. My question is, what would you change on the design of the Bird's Nest if you were to do it over?
Okay, that's a very good question. So by some way of explanation, I would say that the design team on the water cube acted collaboratively from the very beginning. So the architects and engineers, and even specialists, the acousticians, the fire engineers, and facade designers were all part of a single team right from the beginning, coming up with ideas collectively. Whereas on the Bird's Nest, which is a very fantastic, brilliant building, but its way of design was slightly different. There was an architectural and sculptural team that came up with the idea and an engineering team that made it work. It was a two-part process, if you see what I mean. But in answer to your actual question, there is a stadium in Melbourne called Amy Park Stadium, where I worked with an architect called Phillip Cox, and we challenged each other. Is sort of, could we devise a stadium which we felt was as beautiful as the Bird's Nest, but was also structurally efficient and rational at the same time. And it was an incredible journey because we had to trust each other perfectly. If I said to Philip that this form that he liked wasn't actually structurally efficient, he had to accept that. and decide, to look for other forms. And similarly, if I said, well, here's a brilliant piece of structure, Philip, and he said, well, he didn't like the look of it, then I had to move on to find another brilliant structure, if you see what I mean. And we did do that for a couple of months, and I'm very proud of the result. So we have tried to answer your question, actually, in reality.
Great, thanks. Thanks for the answer. Lionel, no questions on the web? Questions here, last one. Anne, last one. Last chance to ask a question.
I have lots of questions. This, again, is moving away from the church, but I read quite a bit about your work. And my question is, as climate change is ravaging the planet, how can structural engineering and design industries combat it? And what is the potential?
Well, I'm glad to say the potential is pretty good. So that's the first. Yeah, I'll answer your last bit of your question first, but then say, why do I think that? So what I've tried to show a bit on Sagrada is by using modern techniques, we can design things that are more efficient, that use less material. Before I start, 20 years ago, the thing that needed addressing was the energy used during the operation of a building and the carbon emissions that came from the creation of that energy, the coal or the gas or the oil that was burnt to create the energy. Yeah. But 20 years on, it's now not the big deal anymore. The operational energy has been reduced by about a factor of 10 in modern buildings, A, but B, the energy now supplied for all electric buildings come from electricity and can be generated by renewables or carbon greenhouse gas more efficient processes. So that's not the issue. The issue now turns to the embodied energy in the structure of buildings. And there are multiple ways of tackling that. The first is to reuse existing structure as much as possible, not always to build new, but adapt existing. The second is to reduce the amount of structure and the amount of material by more efficient design, which our modern computer techniques and virtual worlds and BIM models can all help us do. And also through the techniques of construction, the off-site fabrication, less waste, all of that helps. But the ultimate one, the only real solution, which I think has a good prognosis, is to use carbon-friendly materials, so which typically are biological materials which are directly made by this current sunlight striking the planet. In other words, grown, using current sunshine rather than trying to capitalize on previous energy stores, provided from the past. And I have, despite the combustibility of timber and our need to better understand its performance in fire, which is what we're working on today, I have high hopes for either use of direct timber, engineered timber, or even post-manufactured timber, which I mean materials made from cellulose, which start as timber, or better still as bamboo or grasses, which are even more efficient. And then we're also looking at mycelium and other funguses and other biologically made products, materials for use in other parts of construction, but not necessarily the structural parts.
Thank you.
Okay, thanks, Tristram. So this has been a truly beautiful and enlightening presentation. Thank you so much for your time and for sharing your vision with us. La Maison de l'Architecture a le plaisir de vous annoncer que la prochaine conférence aura lieu le 15 octobre ici au pavillon Cycli. On ne sait pas encore très bien sous quelle forme, mais continuez à nous suivre, restez connectés pour avoir des détails et prenez soin de vous et à bientôt. Je souhaiterais juste qu'on remercie une fois de plus notre conférencier. Thank you.
Merci.